Hello everyone, welcome to the session on Introduction to K-maps. So we all already know that the K-map is a systematic way of simplifying Boolean expressions. With the help of K-map method, we can find the simplest POS and SOP expression, which is known as the minimum expression. The K-map provides a cookbook for simplification. So just like the truth table, a K-map contains all possible values of input variables and their corresponding output values. However, in K-map, the values are stored in cells of the array, and in each cell, a binary value of each input variable is stored. The K-map method is used for expressions containing 2, 3, 4, and sometimes even 5 variables. For higher number of variables, there is another method for simplification called Yuan-Mitlewski method, which we will be seeing in other videos. In K-map, the number of cells is similar to the total number of variable input combinations. So let us just go through the different types of K-maps. So basically we have one variable K-map, two variable K-map, three variable and four variable K-map. This is the type of cells available in a one variable K-map. So the number of cells in a K-map is generally given by the expression 2 power of n, okay, where n is nothing but the number of variables. So if we are having two variables, so 2 power of 2, we will be having 4 cells. Here it is a one variable K-map, so 2 power of 1, which is nothing but 2 cells. So A is the variable because the number of variable is 1. The one variable is nothing but A. The all possible value combination for A is either 0 or 1. So we are going to have two cells. So one cell is going to represent A bar, which is A for 0, and the other cell is going to represent A, uncomplemented value of A, which is A for 1. Okay, and this one is the two variable K-map. Again here, two variables, so 2 power of n, 2 power of 2, which is nothing but 4 cells. So these are the 4 cells and the two variables are A and B. So A will have two combinations, which is A bar and A. Similarly, B will have two combinations, which is B bar and B. So 0 and 1 for A value and 0 and 1 for B value. Next, we are going to the three variable K-map. So again, we can have 2 power of 3, which is nothing but 8 cells. So we can either draw this horizontally or vertically. It is our choice. Anyway, the answer is going to be the same. The product terms will only be differing by the combination of the variables. Otherwise, the answer will be the same. Okay. So on one side, we can take one variable. On the other side, we can take the other two variables. So this side we have taken A, and the other side we have taken B and C. A will have combination of 0 and 1. B and C together will have four combinations, which is 0, 0, 0, 1, 1, 1, and 1, 0. So why are we having the sequence of 0, 0, 0, 1, 1, 1, and 1, 0 instead of 1, 0, and 1, 1? Because that is the usual order, right? So this is because K-map allows only gray code sequence. That is, it doesn't allow 2-bit change at a single time. Okay, suppose we are changing from 0, 1 to 1, 0. Both the variables, that is the first bit and the second bit, will be changing. So 0 will turn to 1 and 1 will be turning to 0. So that 2-bit change is not allowed in K-map. So hence we are going to follow the gray code sequence, which is 0, 0, 0, 1, 1, 1, and 1, 0. Okay. And the next type of K-map is a 4-variable K-map. Here again, we have A, B, C, and D as the 4 variables. Since it is 4 variable, we will have 2 power of 4, which is nothing but 16 cells altogether. So this is how we represent a 4 variable K-map with 16 cells. The possible combinations of A, B is 0, 0, 0, 1, 1, 1, 1, 0. Similarly for C, D, it is 0, 0, 0, 1, 1, 1, and 1, 0. So these are the product wise representation. Okay. So this is the first cell is nothing but the representation of A bar and B bar, which is numbered as 0. The second cell numbered as 1 is a representation of A bar and B, the two variable K-map. The third cell, which is numbered as 2, is a combination of A and B bar. Similarly, number 3 is represented as A and B, product term of A and B. Okay. Similarly, for the three variable K-map, we can just make it as a combination of the horizontal variable and the product of the vertical variable. For four variable K-map also, we will be taking the same way. So this is how each cell in the K-map is representing the product terms of the variables. This is nothing but the min term representation. The first cell will be min term 0. The second cell will be min term 1. The third cell will be min term 2. Fourth cell will be min term 3 and so on. In terms of a 3 variable and 4 variable K-map where we follow the gray code sequence, there alone the min terms will get swapped like this for 3 and 2, 7 and 6, 14, 15 and 10, 11. Since we are following the gray code sequence for the variables. So I hope all of us know the difference between min term and max term. So in sum of product expressions, SOP expressions, we have the min terms. In POS expressions, that is the product of sum expressions, we will be having the max term. So these are the POS expressions. So here, instead of product term of both the cells, here we will have the sum term. Okay. So the first cell will represent A plus B. Second cell will represent A plus B bar. Third cell will represent A bar plus B. The fourth cell will represent A bar plus B bar. Similarly, for the three variable K-map also, it will be the addition of the product terms. Okay. And here again, we will represent the max terms with the capital M. Okay. Capital M is for max terms, POS. And small m is for min term, which is SOP. So the max terms are represented inside the cell so that we can understand better. Hope this video was useful to you to understand the basics of K-maps, the elements, the variables, the numberings, the sequence, and so on. Please comment if you have any doubts. Thank you.